We implemented a HA number router for infinite sequences in Librator, so users can easily locate their residual numbers for any of their sequence. To activate this function, users just need to click any of their sequence, then go to the sequence tab. Then, as we can show here, their sequence will be aligned with the H3 numbering template and showed with the H3 number router. So because of the sequence is the H3 subtype, so by default it will only show the H3 numbering. But actually you can just manually click the H1 numbering to show both routers. Also you can activate the donor region highlights, and all the donor region we just set up will show here from 100 to 200. And as we can see here, we show the original position router of all the amino acid sequences and the H3 number router for your sequence and your sequences. And we highlighted the different sequence elements using different color coding for the HA1 sequences with no color coding, and for the HA2 sequences use a gray background. And also we highlighted the stop codon using red, and the transmembrane region using yellow, and the trimerization using green. And also highlighted the mutations on the sequence and also the N-glycylation site, and we show here. So for those potential N-link glycylation site, we just identify and highlight all the NXST patterns. And on the H1 or H3 number routers, we highlighted all the antigenic sites. For H3, they are A, B, C, D, E, and stock. And for H1, they are CA1, CA2, CB, SA, and SB. So here is how users can access the HA numberings for their sequences. And actually there we also designed another viewers which is more interactive for users to access their HA numberings. Users can just go to the alignment tab, then their sequence will be aligned against those H3 and H1 sequences, and quite similar to previous user interface. As we can show here, we shows all the amino acid sequences, nucleotide sequences, and also the H1 number router and H3 number router. User can choose to display any of those or just hide some of those. For example, this we only show H3 here, and this user interface is highly interactive. It will highlight all the H1 antigenic sites and H3 antigenic sites, and also all the potential unlinked glycylation site. And also when you point at any residues using your mouse, then a red rectangle will indicate your current section, and also your current position will be automatically popped up. So here is the original amino acid position and the H3 number position, and the original nucleotide position. So users can easily identify their residue numbers, and all the antigenic sites and also the lateral patches and the receptor binding sites will be highlighted here, so users can easily find them. And actually, as we showed in the user guide, these epitopes are highly customizable. To customize your current epitopes, you just go to settings, then go to the user-defined epitopes, as we showed here. So here you can change the epitope definition for H1 and H3. And also you can restore the default setting if you made something wrong. As we can show here, we have 13 different color groups for users to indicate different epitopes, and also we have 4 different shade groups and 3 different style borders. So users will have enough combination to annotate their sequences. For example, we just randomly test 1, test 2, we just randomly assign some groups, feature groups, test 5, test 6, test 7. Now we save group setting. After group setting was saved, now we click the annotating residues. So we can use our new groups to annotate all the residues one by one. And for each of the residue, there are color groups and shaded groups and border groups that are independent. You can choose either one or both to annotate your sequences like this. We just randomly annotate some of those. Now we click Save Residue Annotation. After we save, now we go back and refresh the results. Then we can see all the H1 highlight region, we have more annotations just to match what we just saved. Can show here, these are those patterns we just defined. So using this feature, user can easily annotate their database as they want, as we show here. Here is a more complicated example. And furthermore, this user interface is capable of displaying multiple sequences. As we, for example, we just switch back here and we select multiple H1s. Select multiple H1s, then go back to the alignment page. Then it will help us to align all the sequences together with their residue numbers. And here to display the multiple sequence alignments, we have two modes. So the first mode is original mode. Under the original mode, you can only show the nucleotide sequences or only show the amino acid sequences, as we show here, with the potential unlinked glycylation site pattern highlighted. And also we have another mode called template mode. So when we switch to template mode, by default, it will use the consensus sequence as template, and then we only show the sequence difference. So using this function, the user can easily identify all the potential sequence evolutionary patterns and mutations. And we also allow users to set up any sequence as the template to update the alignment. So users can compare the sequences against any of these sequences to easily identify all the patterns. And by the way, this one, so the alignment can be saved for you to add to your slides to present your results. For example, we just click the save image, then just click OK. It will take a while, like usually 10 to 30 seconds. So you just wait here, and yeah, here is something show you is still converting. It may take a while. Then we just wait. After the figure was generated, it pops up, and for example, you can just save here. Click save. Then the figure is saved. We go to the downloads, and as we can see here, the figure has been saved for 3 parts. The first one is a sequence. You can zoom in. It's pretty big. You can zoom in to see all the details. And the second part is to the left is the sequence name, and the third part is the legend. So you can use this section, these figures, in your slides.